Hello folks, this is a part 7 video for the exercise 1.1 and we are going to continue doing the problems about showing whether it's an equivalence relation and so on. This problem, it is defined on the set 1, 2, 3, 4, 5 and they give us a relation R which is defined with all the ordered pairs AB such that the modulus of A minus B is even. Now, one thing that we observe in this problem is that because the set is defined on a very small set A is a very small set, so there's no harm if we list the set, and because once we list the set itself, many things about the set will be clear to us, and like that, like your working becomes like that easier. So let's think of listing it and let's see what happens. So how do we go about listing it? Let A be 1. Okay, when A is 1, you see 1 minus 1 is 0, 1 minus 2 is 1, will not do, 1 minus 3 is 2, will do, 1 minus 4 is 3, that will not do, so 1 minus 5 is 4, will do. These three elements can belong to the relation. Why? Because we should have this even, then only it will belong to the relation. So 1, 3, 5 can belong to the relation. Same way when we take A as 2, 2 minus 2 is 0, 2 minus 1 is 1, 2 minus 3 is 1, 2 minus 4 is 2. So 2 minus 4 also you can list, 2 minus 5 is 3. So therefore here the permissible values of B are just 0 and 2. Suppose A is 3. Then you take 3 minus 3 is 0, 3 minus 1 is 2. 3 minus 2 is 1, that cannot do. 3 minus 3 we have taken. 3 minus 4 cannot be okay. 3 minus 5 is 2. So that should be okay. And then, the permissible values of B over here are 1, 3 and 5. Then we can take A as 4. When A is 4, we know that 4 minus 4 is 0. 4 minus 1 is 3. 4 minus 2 is 2. So 4 minus 2, that also we can take, is 2. 4 minus 4 is 0, 4 minus 1 will be 3, will not do, 4 minus 2 will be okay, that we have taken, 4 minus 3 will be 1, will not do, 4 minus 5 will not do. So these permissible values of B are only 2 and 4. Then when A is 5, 5 minus 5 is 0, 5 minus 1 is 4, that's permissible, 5 minus 2 is 3, 5 minus 3 is 2. So that's permissible. 5 minus 4 is 1, that's not permissible. 5 minus 5, yeah. So the permissible values of B are 0, 2 and 1, 3 and 5. Right? So let's list the relation and let's see what comes in this relation. The relation R therefore will come to, R will be, for 1 we can have 1 comma 1, we can have 1 comma 3, we can have 1 comma 5. For 2 we can have 2 comma 2 and 2 comma 4. For 3 we can have 3 comma 1, 3 comma 3, 3 comma 5. Then for 4 we can have 4 comma 2, 4 comma 4. Then for 5 we can have 5 comma 1, 5 comma 3 and 5 comma 5. These many elements are there in the relation. So when you have to show the equivalence relation, certain things we can directly take from here and write, and certain things we'll have to prove. Like it depends on the complexity of the thing. Like for reflexive, we can take it from here. 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there, 5, 5 is there. So they are all reflexive. See, 4, 4 is there, 5, 5 is there, 3, 3 is there, 2, 2 is there, 1, 1 is there. So like that it is reflexive. So certain things we can take directly from the set and answer, or certain things we can maybe prove. So reflexive with T, since 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 belongs to R. You can write A comma A belongs to R for A belonging to A, like that also you can write. So since all this is belonging to R, therefore R is reflexive. So that's done. Then we can go for symmetricness. Now symmetricness and all, no, it's very strange relation, because it's not possible, no matter whatever you take, there would be some relation that you may skip. That is why it's always better to prove it in general. Symmetricness and transitivity is better to prove in general when there are so many elements in the relation. Quite many elements are there. So we'll take a general thing like A comma B belong to R. So what is the meaning? That modulus of A minus B is some 2m, where m is some integer. Why? Because it's an even number, means it's 2 into something, that we know. So therefore it's some 2m probably. A minus B, modulus of A minus B is nothing wrong if you say that it is B minus A. It's going to be the same, because modulus will take care of the thing. Even if you do 3 minus 5 or you do 5 minus 3, when you take the modulus, the value is going to be the same. So that is why there's no harm if I call it as B minus A. But moment I call it as B minus A, then I can change the element and I can call it as B comma A belongs to R. So starting with AB belonging to R, I have got BA belongs to R, like that R is symmetric. Therefore R is symmetric. Right, so that's about symmetricness. Then we can go for transitivity also. I think it's better if we show like this a general statement. Transitivity, let A comma B and B comma C belong to R. Right. So what does it come by definition? It means that therefore A minus B is some 2m1, and which means that for some m1, that is a integer, and B minus C is some 2m2 for some m2, which is an integer. But basically if you want to write it without the modulus, it also means that therefore, like if I will say that it is just A minus B, there's no harm in calling plus or minus 2m1. There may be a sign change. When we take the modulus and when we don't take a modulus, it's just a sign change. That's all. Whenever we take the modulus, we'll always get the positive value, but whenever you try to skip the modulus, sometimes you may get a negative value also. So we take both the, you just remove the modulus and take both the values. Similarly, you will have B minus C also becoming something like plus or minus 2m2. Right. So what have we got? We've got this A minus B and we've got this B minus C. In transitivity, we are more bothered about A minus C. So therefore consider this A minus C. Yeah, and that is A minus B plus B minus C. No harm in writing that. Minus B plus B we have introduced. Net effect, the value doesn't change, but it helps us. Why it helps us? Because A minus B is plus or minus 2m1 we know, and this is also plus or minus 2m2 we know. So basically it is 2 times plus or minus m1 plus or minus m2 depending upon the case, right? So it is 2 into something basically. So in net effect A minus C, depending on what value that comes up over here, we can have is even. Yeah, we can generalize that this is even. So as a result, what happens is thus, when it is even, we can say that A comma C belongs to R. Thus A comma B and B comma C belongs to R implies that A comma C belongs to R. Therefore R is transitive. Right. So that is our third relation. Now therefore from 1, 2 and 3, R is an equivalence relation. Now that's not all. There are many things that is being asked in the question. So let's go through the question and let's see what extra things they have asked us. They have told us that show that it's an equivalence relation. After that they say that show that all the elements of 1, 3 and 5 is related to the to each other, and all the elements of 2, 4 are related to each other. No element of 1, 3, 5 is related to 2, 4. Right. So we see that, we observe that in R, see 1 is related to 1, 1 is related to 3, 1 is related to 5, 3 is related to 1, 3 to 5, 5, 1, 5, 3, 5. So in 1, 3, 5, only these elements are related to each other in R. We observe it, we saw it, that 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, then 5, 1, 5, 3, 5, 5. Okay, if you want you can write, because you have 1 1, 1 3, 1 5, then 3 1, 3 3, 3 5, 5 5, 5 1, 5 3, 5 5 belonging to R, and elements of 2 4 related to each other in R. In R, since 2 is related to 2, 2 is related to 4, then 4 is related to 2, 4 is related to 4 in R. Right, they are only related to each other. There is no element from 1 3 5 related to element 2 4. But no element of 1 3 5 is related to 2 4 from the listing of R. We have listed the R, so from there itself we can find out that nothing is related to. So that's how the question is. There are so many things in that question. Is there yes, that's all. In the next sub question they ask something related to one and all that we can see later. So that's about this part. I think we should conclude this part because it's a huge problem. So the next two problems we will be taking it up in the next part. Thank you.